Okay, we're in the examples. And when I put the examples, for the most part, I think probably you could read through these things. You may not understand exactly what to do, but I hope you have some impression. That I want to just, before I do anything, I want to point out, this is an exponential problem. There's a power over here. All right. So the thing is, it says, you build an annuity. Now, whether you know what that is or not is incidental to me. What's important is they've given you some formula over here. And we'll discuss that piece by piece. It says you build an annuity by investing P dollars every month at an interest rate of R, compounded monthly. All right. Find the amount A accrued after N months using the formula. So let's go back over here. All right. And I want to write down what they've given me. Right. Each thing they've given me the P. What's P? 119. What does that mean? That's the amount of money every month you're giving. $119 per month. What's the R? Well, the R is going to be 0.09. Now, what does that mean? That means 9%. All right. You don't want to write 9% down, but that's what that means. Let me get my eraser out. Okay, let me keep going. What else do they tell me? They tell me the N is 52. Here comes the tough part for students. They've got to do this on a computer, and we'll go through that. But I want to write down first, what do you get? A equals, right, what does A equal? It equals P. What's P? 119 times, here comes the tough part, 1 plus, let me simply copy what I got down. What's R? 0.09 divided by 12, caret, what's N? 52, minus 1, I know this looks strange to you, divide by, well, I'm going to put, this down over here, and it's going to be R, which is 0.09 divided by 12. Now, people screw up. We know that. So what I'm going to claim over here is that I want to just briefly talk about the use of Sage. Now, I have to switch screens now. And when I do that, I'm going to point out, I'm going to use Sage as a calculator. All right, I'm going to do a new share. I'm going to use Sage as a calculator. All right, let me go through that with you. I'm just typing what I'm seeing. 119 star, oops, sorry about that. Parentheses are used for grouping. I see two parentheses, so it's going to be 1 plus 0.09 divided by 12. I'm just typing what I'm seeing on my whiteboard now, and I'm hoping you're taking notes and you're able to do this too. Again, if it goes too quickly for you, you can always come back later in the week and do this yourself. All right. You really want to practice though. Practice using a computer. What am I dividing by? And you're going to make mistakes. I make mistakes a lot too. So 0.09 divided by 12. And if I make a mistake typing in Sage, Sage is going to say you made a mistake. I don't know. Let's see what happens. Well, it gives me a number. I'm going to write the number down for you. And since it's a money problem, when I write this on a whiteboard, and I'll switch back to it in a second, I'm going to just, write the number down I'm seeing, but I'm going to write that as a money number. What does that mean to two places? So that's going to be 0.2. But again, this is a money number. How do I know that? Well, I read the problem. So what I want to do is I want to go back and share my whiteboard again with you. I just did the computation on this thing over here. And let me just go back to my whiteboard. Give it a second. Okay, so I just copied the number down. What I copied down, 753402. I wonder, did I get it right though? No, sometimes I type things in correctly, and I'm not really thinking at this point. I'm just wondering, did I get it right? So I want to go over here and I want to point out, I'm looking at this number and I'm looking at this, and I got it right. $7,534.02. All right, let's go to the next one. It's going to be number 2. And what's number 2? It says, use the discrete compound interest formula. Well, you would need to know what that is, and I'll write it down for you. And again, if you don't remember, go back in the notes. So A is a function of time. It equals P times 1 plus R over N. N is the number of times we compute it per year, raised to the power NT. All right, so let's write down what they've given me, and we'll go through it. But I'm reading it. It says use the discrete compound interest formula. Well, that's right there. It says amount of money after 20 years. So T is 20. T is time in years. And initial deposit, that's P, is 30,000. And it's compounded monthly. That means N is 12. It's done 12 times per year. And the interest rate is 12%. So the R is 12%. I'll write this over here. So I'm actually gonna put that down for you. So A 20, we'll go to Sage later, is 30,000. I'm sorry about that. Oh, that's multiply, right? A little star there for you. 1 plus, what's R? Well, 0.12. And what's N? Well, it's 12 times per year. And it's raised to a power. And what's the power going to be? Well, N, which is 12 times 20. I'll write that down for you. So it's raised to the power 12 times 20. I'm going to go to Sage now, and I'm going to use Sage as a calculator to do this computation. So I'm going to switch screens now. I know it's frustrating, but you want to learn to use a calculator. All right. So I'm going to do a new share. I'm going to go back to Sage. And I'm going to type that computation in. And what is it? 30,000. Remember, if I make a mistake, nothing's going to happen. I'll know I made a mistake if I just simply look at my answer key, though. And that's what we're trying to encourage you to do. 1 plus 0.12 divided by 12. Make sure you have this written down, by the way. And we're going to raise it to a power. What power are we going to raise it to? 12 times 20. Let's see what happens. I'll write it down. And when I write down, I'm going to use my little approximate, and I'm reading that number. It looks like 326,776. And this is a money problem. What am I going to get? 61. I could have made a mistake. I'm not saying I didn't. So what I want to do is I want to go back to my whiteboard and see how I did. And it's not that I copy wrong. It's possible, you know. Give it a second to warm up. All right. So I'm saying it's, $326,776.61. Well, I'm going to see if I got it right. I don't know. Maybe I got it wrong. Let's take a look. We want you to do this as well. 326,776. Gee, I got that right. And 61. I got it right. All right, let's go to the next one. The next one is going to be number 3. All right, number 3 has a graph to it. Now I'm looking at number 3, and I'll write it down for you. And what is going to be f of x equals the opposite of 2 raised to the power 1 minus x. Now, granted, someone says, oh, you gave me a picture. Why don't I just simply trust you on it? We're not asking you to trust. What we're asking you to do is to verify what we're saying is true. And what I would do over here is I would do a table of values. And it's tough. I'm not saying it's going to be easy for you. I want to point out that y is a function of x. So what would be the easiest number to choose? I'm going to say 0. All right, would be easy to choose. And what would you get? Well, if you put that down, you're going to get this. This is confuse a lot of students, by the way. It would be 1 minus 0, which is 1. What does that give me? Minus 2. Right, I'm going to go over here. I'm going to plot that point for you. So 0 minus 2. All right, let's do another point. In terms of what point you're going to choose, I would probably choose 1. Right, I'm just learning. So what'd you get over there? That would equal minus, that's the opposite, right? 2 to the 0 power. What would that give me? Minus 1. Let me plot that point for you. So 1 would give me minus 1. That's pretty simple. Now, someone says you could connect those dots together in a reasonable way. I would say something like this over here. That's reasonable to me. All right, let me do another number. And someone says, when are you going to stop? Well, maybe never. Maybe I'll never understand. There's going to be 2. What do you get over there? Minus 2. And what would you get? 1 minus 2 would be minus 1. So what would they give me? The opposite of a half, which would be minus 1/2. Well, let me plot that point down for you. So 2 would give me minus 1/2. And I'm starting to see it now. I'm going to say as we start moving to the right, what's happening? It's starting to move up slowly. All right. Now, if you don't see that, what would you have to do? You'd have to take more and more points. For example, if you took 3, what would you get? minus 2. Well, 1 minus 3 is minus 2. That would give me minus 1/4. If you did 4, I think you could probably predict this now, be minus 1/8. Let's go in the other direction, minus 1. Let's see what you get. Minus 2. You would get 2 at the top because 1 minus a minus 1 is 2. What's going to give me minus 4? Let me plot that point. And again, I'm plotting it on a curve. That's right over here. All right. And what's the next number I would choose? Probably minus 2. What would that give me? 1 minus a minus 2, which would be minus 2 cubed. What's that going to be? Minus 8. Now, someone says that's not even on the picture, and you're right about that. It's over here somewhere. Put it down. All right. So I'm going to connect the dots together. It's tough. It's something like this. Now, someone says, well, you gave me the graph. That's why you could do it. Well, you're learning. All right. Now, what else do I notice about this graph over here? I want to put this down for you. What do I know about f of x? F of x is always below the 0. All right. Always below the 0. It's never above the 0. And I'm going to say there's a horizontal asymptote. And what's that going to be? Y equals 0. I clearly see that in my picture. All right. This is all written down for you. I want to point out, you probably should take a careful look at that. Basically, it's connecting dots together with behavior. All right. Looks like an exponential. Comes from the family. All right. Let's go to the next page. And we'll do problem number 4 now. What's problem number 4? Let's take a look at it. It says use the, it's continuous compound. Do I remember that? Well, if not, I can always go back to the notes and look up the formula, right? So number 4. And what's it going to be? A is a function of time. This is continuous. And that's going to be P to the E R T. All right, let's write down what they've given me. And we'll do SAGE again. All right. So what do I know about this? I'm reading it. It says T is 40 years. All right. What does it say? It says the initial deposit, which is P, is $15,000. And it goes on and says the interest rate, R, is 9%. All right. Let's write this down, and then we'll go to SAGE. So A is a function of time. P is 15,000. And then what I'm going to do is over here is, times, I'll put a little star there for you. E raised to the power. What power is it going to be? Well, it's going to be RT. So I'm going to say 0.09. That's the R. And what's the T? The T is 40. Now, someone says, could you do some of that written up by hand? Of course I can. But my goal is to go to SAGE. And I want to go to SAGE now. All right, let's do a new share. And we're going to go to SAGE. Just give me a second. And the first thing I'll do is, look at this thing. And I'm just going to type in the letter E and see what happens. Well, gee, it gives me that. Let me put in E. I'm just playing. To the power 2.0. I'm just playing around now. I want to see what happens. Well, let me put in E raised to the first power. I want to see what happens. Gee, that's recognizable. That's E, isn't it? So what does this mean in SAGE? The letter lowercase e in SAGE indicates Euler's number. Well, I'm going to type the formula in now. So it's 15,000 times E raised to the power. What's the power? 0.09. And I'm not beyond making a mistake, and nor are you. You want to try your best. We have an answer key for you. And I'm going to write down what it gave me. All right. I'm going to write down, I'm going to approximate it. Again, use my whiteboard to go back to the second. 548,973.52. And someone says, why do you round up to 2 decimal places? It's a money problem. Let me go back to my my whiteboard. And again, I know we're going back, and some people find that annoying, but you need to learn to use a calculator. And I'm going to go back to the whiteboard now. And I'm at the whiteboard. And I just simply copied the number down on my whiteboard. I want to go to the notes. I want to see if did I do okay. And let's take a look at it. And I want to see if I got the right number. And I'm looking at this over here. And it says 548,973. Gee, I got that right. And well, I did it right. This is good. All right. So this is great news. All right. Let's go to the next one. And this is really old news for me. And what does it say? What type of transformation? And again, I want to point out what I mean by that. It says, what type of transformation? We're hoping you remember the past. What type of transformation? We have a parent graph, f of x, and they're wondering what this one over here. That couldn't be easier. And I want to point out what I mean by that. They're just asking what happened. Well, the parent graph, f of x, has been shifted 1 unit to the right. Let's read it. It's horizontal, by the way. So what's it say over here? The graph is a horizontal shift 1 to the right of this guy over here. So if you were to look at that, 3 to the x, and I'll give you a rough picture of what that looks like. And let me just put this down for you. 3 to the x looks like this. This is f of x equals 3 to the x. Well, again, no, I'm not putting any numbers down over there. But what would the other guy look like? It would look like that graph moved 1 unit to the right. And certainly it might be hard to detect, but something like this over here, moving it 1 to the right. So f of x minus 1. It's 1 unit to the right horizontally. All right, let's go to the next page. And this all stuff's written down for you. You can play around with that if you want. And we got some pictures over here. And let's take a look. All right. So over here, number 6. And we'll get to the pictures later. Number 6 is use a calculator. Let me point out what I mean by that. If I were to do this over here, it's going to be f of 2/3. What does that look like to me? 2.3 raised to the power 2 divided by 3. Well, I'm going to go to Sage. And let me just switch screens again. And again, I hope you're not frustrated by switching screens. And I'll do a new share. And I'm going to do the Sage again. And I'm going to type it in. What is it? 2.3. I'm using Sage as a calculator. It's the simplest way to use Sage. Raised to what power? 2 divided by 3. And by the way, I may be shocked that it may actually spit back something I don't expect to see. And what am I seeing over there? Let's write this down. Again, I'm using my whiteboard. I'll come back to it later. And they want me to do it to 4 decimal places. And I'm going to write down what I'm saying, 1.7424. Let me go back to my notes. And I want to point out what I did in Sage. I got this, and it's matching exactly what they said it's going to be. All right, let's look at number 7. Number 7 looks like a relatively simple one. And again, their question is, what type of transformation? Well, this is the parent. I know what that looks like. We've done that in the early part of the lecture last time. And what is this guy over here? The graph of this thing over here? It's really simple. I mean, that's really going back to the beginning of I can't say the beginning of the course, but near the beginning of the course, where we talk about transformations. And what's this transformation here? It's going to be a rotation about the x-axis. Clearly indicated over there. All right, let's do number 8. And when I do number 8, I will look at the picture. We're trying to get you guys to think about the pictures that we're presenting to you. And I'll go over here, and it's this guy over here. Now, if I were doing this problem over here, my claim over here, if I were doing this problem over here, I'm given a good picture, by the way. And what I'm going to do is, whoops, sorry about that. What I'm going to do is I'm going to write down what f of x is. And what's f of x? It's 2/3. That's a fraction, by the way. And I'm going to do a table. What goes in my table? And this is a function, y is a function of x. I'm going to say 0 would go down. That's the simplest one to put down. What's 2/3 of 0? 1. I'm going to plot that point. That's done. Let's take another point. All right, so what other point would you pick? Probably 1. What would 1 give me? 2/3 to the first power, which would be 2/3. Let me plot that point. So 1 would give me 2/3. All right, yes, it's a fractional number. I know that. Let's do 2. I'm getting a feel. That's going to be 2/3 squared, which is 4/9. Now, you realize 4/9, roughly speaking, about a half. Let me put that down. So 2, roughly speaking, about a half. Let me keep going. Next number. Again, remember, you go as long as you like. 3. What is that going to give you? Well, that's going to give me 8/27. All right. Now I'm going to say, roughly about a third. All right. This is rough. So when I get over to 3, I'm about a third. I think you get an idea over here, what's happening over here. At least I hope you do. And someone says, well, I still don't see it. Take another number. What's that going to give you? 16/81. All right. It's even getting smaller. And I think for the most part, you got a really good idea what's happening in this direction over here. Now I'm going to say it keeps going down. All right. Let's go the other direction. Let's do -1. What would that give you? 2/3 to the -1, which would be 3/2. That's 1.5, right? Let me put that down for you. That's done. Let's do -2. What would -2 give you? Well, that would give you 9/4. Yes, you have to be able to do arithmetic. What's that going to be? 2.25. Let me put that down for you. I think I get the idea. And again, we're looking at this. It's growing. We're going to write some information down over here. I'm going to say f of x is always greater than 0. It has a horizontal asymptote. What's a horizontal asymptote? Y equals 0. This thing is always decreasing. How do I know that? Look at the picture. And the picture clearly is a picture of a decreasing function. As I move left to right, it's always moving down, always moving down. All right. Any x-intercepts? No. Is there a y-intercept? Of course there is. 0, 1, yada, yada, yada. All right. Let's go to the next graph. And again, the graph should be relatively simple to construct. All right. So let me just point out what we just did. We just did number 8. Now I'm going to do number 9. All right. And number 9. So over here. All right. Write this over here for you. And how am I going to do this? Well, I'm looking at the function. I'll write it down for you. F of x. Whoops, I'm going to go back to white. F of x equals 3/2 to the x minus 1. And you'll get better over time. I promise you that. Let's put a table down. Someone says, what's an easy point for you to choose? Well, believe it or not, I'm going to choose 1 this time, and then 2, and then 3. And then I'll do 0, -1, and -2. Let's try the 0 first. And what would you get? 3/2 to the -1, which is 2/3. Let's try 1. You'd get 3/2 to the, 0. That'd be 1. That's easy. Let's try 2. You would get 3/2 to the 1, which is 3/2. You'd have a sense of numbers, by the way. And this is 3 over here, by the way. If you chose 3, you get 3/2 squared, which is 9/4. Again, you can keep doing this all day long if you want, but the bottom line is you don't want to do it all day long. You want to see if you can figure out what this thing looks like by plotting a few points. If you took -1, you get 3/2 to the -2, which is going to be 4/9. You should see reciprocals in these problems that way. If I did -2, what would I get? Well, -2 minus 1 is -3, and 3/2 to -3 is going to be like, 2/3 cubed, which is 8/27. I'm going to plot the points out. Easy peasy, lemon squeezy. 1, 1. Right there. That was easy. 2 3/2. 3/2 is 1.5, by the way. And 3 9/4. And what's 9/4? That would be 2 1/4, right? So up here somewhere. I get an idea. If I looked at that, I'm getting an idea that it's going up. All right. Predicting. All right. Let's go in the other direction. And what would I get? Let's see. I would get 0 2/3. That's about 2/3 up. -1 4/9. -4/9, about 0.5. And then -2 8/27. I'm getting a feel for this. I'm going to say it's going down. All right. So what I'm going to write over here is that f of x is always greater than 0. That's always. All right. I see a horizontal asymptote. And what's horizontal asymptote? Y equals 0. And this thing's always increasing. Look at it. Left to right, it's always going up. All right. Always going up. All right. Let's go to the next page. Let me make sure I did that. That's number 9. And let's go to number 10 now. And number 10, for a lot of students, they look at this. I don't even know what you're asking me to do. They want you to insert a symbol. And they're either saying it's going to be this symbol here or this symbol. It's one or the other, not both. All right, I wonder which one goes over there. So I'm going to write this down over here. I don't know. Let's take a look at this over here. And I'm going to put down 8. Whoops, I go back to my red ink here. Let's go blue. So 8 to the 3/4. I'm going to put an equal sign here with a question mark. I have no idea. And 3/4 to the 8th power. What I would do is I'd probably raise both sides to the 4th power. All right, that's not so bad. What do you get? You would get 8 cubed is 3/4 to the 32nd. I'm going to say at this point here, and there's a question in between it, I'm hoping you know clearly which one's bigger. All right, I want to point out what I mean by that. I'm looking at this over here, an 8 cubed, not that I want to compute it. 8 cube's a big number. What's this thing over here? 3/4 to the 32nd power is an incredibly small number. And why is that? The bottom is growing faster than the top. This is a proper fraction. 3 to the 32 is smaller than 4 to 32. This is a small number. So I can put my symbol in now. And let's put that down for you. I'm going to get my eraser out. I'll write this down for you. All right. And that's it. Thank you for your attention. What are you going to do now? Study the material we presented to you, and then try to do problems on your own. Thank you.